Hello everyone, thank you for joining me here for Math 120 section 5.2. Today we're going to start off with some review of additions and subtractions. So, add the following using the number line below. So, the number line below, 3 plus negative 5. The reason I wanted to look at the number line below is because I wanted to show you that if you start here at 3 and I want to add negative 5, negatives are backwards. So adding negative 5 would be counting 1, 2, 3, 4, 5 steps in the negative direction to negative 2. So 3 plus negative 5 is negative 2. Now, will we use a number line every time we add positive and negative numbers? No. The number line will just help us get used to the rules. Next, negative 1 plus negative 4. So negative 1 is where I start. And adding negative 4 means to go left 4. 1, 2, 3, 4 gives me negative 5. Now, in the third example, I start at negative 6, and I want to add 4. This 4 is regular old 4, so it's positive 4, right? So I go 1, 2, 3, 4. That gives me negative 2. And then lastly, 3 plus negative 3, I start at 3, go left 3, 1, 2, 3, gives me 0. So the number line helps me keep track of which direction I am shifting. Am I making the number larger or smaller? Am I moving to the right or to the left? If you ever get tripped up in your plus and minus signs, always feel free to refer back to a number line. Now, subtraction, aka adding the opposite. If I have A plus B, that can be written the same as A minus negative B. Notice the subtraction had opposite signs. Similarly, A minus B can be written as A plus negative B. I can turn subtraction and addition back and forth to each other. Now once again, we won't frequently use the definition once we get the hang of how to work with the signs, but this will help us to begin with. Now let's take a look here. We have negative 4 minus negative 3. And I want to use the definition and the number line. Well, I want to add the opposite. So I want to do negative 4 plus, what's the opposite of negative 3? Positive 3. So I'm adding the opposite. So I start at negative 4, and adding 3 is going 1, 2, 3 spots to the right. Gives me negative 1. So I added the opposite. So that's how we can do subtraction. We can always turn subtraction into addition. So you only need to know how to add, because if you can add, you can subtract. So let's try some subtractions. Let's try and think about these without using the number line, though. Let's try and think about them as adding the opposites. Negative 5 minus 3. Well, if I want to add the opposite, negative 5 plus the opposite of 3 is negative 3. Negative 5 plus negative 3, if you think about it, will become negative 8. Remember, you move the leftwards direction on the number line when adding a negative. How about negative 5 minus negative 3? Well, if we're trying to add the opposite, that's going to be negative 5 plus the opposite of negative 3 is positive 3. Negative 5 plus 3, increasing negative 5 by 3 will give me negative 2. Remember, I move 3 spaces right on the number line. 5 minus negative 3, if I want to use the definition of subtraction, would be 5 plus the opposite of negative 3 is positive 3, and that just gives me plain old 8. A lot of people like to think of this as double negative, right? It's a double negative, so it becomes a plus. A lot of people like to think of it like that. And then the last one, 5 minus 3, hopefully we can all agree that is 2. Now notice, all of these were just the numbers 5 and 3 with different combinations of minus signs and negative signs. But I got 4 different answers. It's important to know how the signs work with each other, and it's important to make sure you're not making any sign errors as you work with these positive and negative numbers. Because real-world applications have positive and negative numbers. The highest point in the U.S. is Mount Denali, Alaska, at a height of 20,237 feet above sea level. So I've got 20,237 feet above sea level. Above sea level would be a positive number, right? So I'll keep this number. Let's see. That's the first sentence. The lowest point in the U.S. is Death Valley, California, at a depth of 282 feet below sea level. So that's going to be a negative number. So this was Denali, and this was Death Valley, right? How did I know it was negative? Below and depth both hinted that the number was negative, right? Those are terms that tell us it was below sea level. It was a negative number. Then it says, determine the vertical difference. So I'm going to be subtracting. Difference means to subtract between the two elevations. So I'll take the height of Denali and subtract the depth of Death Valley. Notice I have a double negative. The Death Valley number was already negative itself. I need to make sure I know that. And I need to make sure that the difference tells me to subtract. So, double negative, using the definition, will become a plus. And I'm going to get 9, 1, carry the 1, 5, 0, 2. And then we should always double check our calculator. 20237 plus 282. Oops. Gives us, I typed it in wrong. There we go. So I added it right in my head, but added it wrong on the calculator. Always good to double check though, right? What did I forget though? Units. Gotta put feet. Always put your units. Always put your units. Now, multiplication. Let's shift away from add and subtract to multiply them. Multiplication property of 0. Anything times 0 is 0. Also, 0 times anything is also 0. 0 is definitive in multiplication. Next, what are the rules for signed numbers? What happens if I have signed numbers? What's a positive times a positive? Well, that's a positive, right? I'm going to abbreviate positive and negative to just the first 3 letters. Feel free to do the same. Positive times negative is going to be negative. Negative times positive is going to be negative as well. But negative times negative, that is positive. So if they have the same sign, they multiply to be positive. If they have opposite signs, they multiply to be negative. And that's what this showed us right here. So let's look at some examples. 5 times 6. They're both positive, so they multiply to 30. 5 times negative 6. Well, one's positive, one's negative, so the answer will be negative, and it's still going to be 30, because 5 times 6 is still 30. Negative 5 times 6. One's negative, one's positive. They have different signs, so the answer will be negative 30 again. Then lastly, negative 5 times negative 6 will give me positive 30. They have the same sign. And then I have a little note here that we didn't have to write this multiplication sign, right? If it's next to the parentheses, it's assumed to be multiplication. 5 times negative 6. So that's multiplying. What about dividing? Let's talk about dividing by 0 first. So here, the letter A is not 0. And so 0 over A, 0 divided by any number that's not 0 is 0. A over 0 is undefined. We cannot divide by 0. That's a no-no. No dividing by 0. And lastly, what about 0 over 0? How does 0 over 0 work? Some people might want to say 1, because anything divided by itself is 1, but that's not true for 0. Now, is it going to be 0? Maybe. Is it going to be undefined? Maybe. Which is it going to be? It winds up also being undefined. 0 over 0 is also undefined. You can't simplify 0 over 0, because you're still trying to divide by 0. So just remember, 0 over any non-zero number works out to 0. But anytime you have 0 in the bottom, it does not work out. You can't divide by 0. You can never have 0 in the denominator of a fraction. You can never divide by 0. Now, what are the division rules for numbers? Just like before, I'm going to abbreviate, but positive divided by positive is positive. Positive divided by negative is negative. Negative divided by positive is also negative. But negative divided by negative, that's back to positive. Same as multiplication, same rules. Just the word divided instead of multiply is in between, right? Same rules. If they have the same sign, they're positive. If they have opposite signs, it's negative. So let's take a look here. 63 divided by 9. Well, they're both positive, so that'll be 7. Negative 63 divided by positive 9. They've got different signs, so it'll be negative. Still going to be 7, though, right? 63 over 9 is still 7. 63 divided by negative 9. Once again, different signs. So my answer is negative, and we're still dealing with 7, because 63 divided by 9 is still 7. And then lastly, negative 63 divided by negative 9. Negative divided by negative is positive, and so it'll be positive 7. So we can keep track of our rules for multiplication and division, right? Make sure you're comfortable with the sign rules. Now, how about exponents? We talked briefly about exponents in the last section. We briefly mentioned them, but we're going to go into more detail here. Exponents are shorthand for repeated multiplication. It's shorthand for repeated multiplication. And our first example, 5 to the second. The 2 tells me I want 2 copies of the base. 2 copies of 5. 5 times 5 gives me 25. So that is the first answer. 5 squared is 25. How about negative 3 squared? Well, negative 3 squared, I'm going to take 2 copies of negative 3. Negative and a negative make a positive. That'll be positive 9. Now, the third example. Notice the negative sign is outside of the parentheses. It's basically the same thing, just without parentheses, right? Negative 3 squared is telling you to do 3 squared first and then make it negative. Think of it as negative 3 times 3. Notice I only wrote the negative sign once because it wasn't in parentheses. That's the difference between these two examples. With parentheses, you duplicate the negative sign. Without parentheses, you keep it separate. So this one becomes 3 times 3 is 9, and it stays negative. Notice I didn't get the same thing, right? That's the difference between the parentheses and not parentheses. How about this one? 1 to the 1,234. 1 to the 1,234. Well, I could write out 1 times 1 times 1 times 1, 1,234 times. Should I? What's 1 times 1? 1. Times 1, 1. Times 1, 1. Times 1, 1. This is going to be 1, right? It doesn't matter how many times I multiply 1 by itself, it's always going to be 1. And then how about here? We have 10,734,501 to the first power. So how many copies of this number do I want? I want 1 copies. 10,734,501. The first exponent just leaves the number the same. To the first power doesn't change the number. Our sixth example, we're back to negatives. This one does not have parentheses. So I'm going to write negative 2 times 2 times 2 times 2. I take 4 copies of 2, but not 4 copies of the negative. 2 times 2 times 2 times 2 is 16. So that'll be negative 16. Here, I take 4 copies of what is inside the parentheses. Because the 4 has parentheses for the exponent. I want to take 4 copies of that negative sign. That's the difference. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. So notice I got different answers again. Negative 16 and positive 16. You need to be careful of the parentheses. Our eighth example, once again, I take the negative sign, and then I take 5 copies of 2 because there was no parentheses. I don't duplicate the negative sign. So it'll be negative 2 times 2 times 2 times 2 times 2 is 4, 8, 16, 32. So I get negative 32 for my eighth example. And then lastly, notice the parentheses. So as I write, I'll be duplicating everything within the parentheses 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 and negative 2 make negative 4 times another negative 2 is positive 8. Or sorry, let's try that again. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8 times negative 2 is positive 16 times negative 2 is negative 32. Huh. I got the same thing when it was to the 5th power, but I got different answers when it was to the 4th power. I wonder why. I wonder if there's a reason. That's something to think about, right? Try thinking about it. If any of you who tune into the live session, whenever that may be, feel free to ask if you want for more clarification. But think about it for the time being. Why did I get different answers when the power was 4, but the same answers when the power was 5? Good to think about. And then note, observe the importance of the parentheses and the different answers that result from their inclusion or absence. Sometimes we get different answers. Think about it. Why do we get different answers? How come we got the same here? Next, we're going to combine everything we just talked about into one concept called the order of operations. Now, the order of operations has 4 steps. Step 1 is work inside the grouping symbols. What are the grouping symbols? Parentheses, brackets, braces, you know, the grouping symbols, the symbols that group numbers together. Step 2 is apply exponents. Step 2, you apply the exponents. Step 3, we multiply and divide from left to right. You multiply and divide at the same time. Which one do you do first? Whatever's on the left. You work left to right. Sorry, I guess left to right. Then, the last step, we add and subtract from left to right. And just like with multiplication and division, you don't add first unless it's on the left first. You always go left to right. There's only 4 steps in the order of operations. Now, some of you might be thinking, what about PEMDAS? And PEMDAS is misleading. PEMDAS makes it seem like you should always multiply before you divide. That is not true. You multiply and divide at the same time. If I wanted to write PEMDAS here, I could write P, E, and then this step would be M and D, or D and M, right? If I wanted to talk about the order, it can be either or, right? I go left to right. And similarly, this could be subtract then add, or add then subtract. PEMDAS is misleading. There's only 4 steps in the order of operations, not 6. Only 4. And so let's take a look here. Let's look at our first example. 100 minus 3 times 5 squared plus 8. What do I do first? Grouping symbols. There's none. Skip to the next step. Apply exponents. Exponents. Equals 100 minus 3 times 5 squared is 25 plus 8. So I did my exponents. Now I multiply and divide from left to right. Multiply. So I get 75 there. I'm going to multiply next. 100 minus 75 plus 8. So I've done all, there's no more multiplications, divisions. I move down here. I add and subtract from left to right. So I go left to right. I subtract first. I do not add first. I subtract first. Make sure you don't mess that up. It can be easy to get confused, especially if PEMDAS is stuck in your head. Always left to right. 100 minus 75 is 25 plus 8. And then only one thing left to do, add those together to get 33. So my final answer, 33. Notice we went one step at a time, right? We walked through the order of operations a single step at a time. How about the next one? Let's write it out. 41 plus 23 divided by 8 times 13 minus 15 squared. What am I going to do first? Well, first I work inside my grouping symbols. I have a group here and a group here. They're separate groups though, so I can work them both at the same time. 41 plus 23 gives me 64 inside that parentheses, divided by 8 times, in this parentheses, 13 take away 15 is negative 2, right? 13 minus 15 is negative 2. And don't forget the squared. So I worked inside my groups. I'm done with that step. Now I apply exponents. There are exponents, so I'll do this next. Notice it's an exponent with parentheses around the negative number. So I'm going to get negative 2 squared. Do I keep the negative when I apply the exponent, or do I leave it out front? Well, with parentheses, you duplicate the negative, right? So this would give me 64 divided by 8 times negative 2 squared is positive 4 when all is said and done, right? So I applied my exponents. Next, I multiply and divide in what order? Left to right. So I'm going to go right here to divide next. We do not multiply next. We divide next because it's on the left. 64 divided by 8. That looks to be about 8 times this 4. I don't really need those parentheses anymore, do I? They're just kind of holding that 4 in place because 8 times 4 is 32. So I worked my steps in the same order as I did in the other one. The order of operations. It's always the same order. It will always work out for you if you follow the order properly. Make sure you are getting used to using the order of operations, right? We want to be used to following the steps correctly. And I believe, yes, that brings us to the end of section 5.2. Thank you for joining me, and I will see you all next time.